My bad. Okay, so we conduct technical workshops ranging from data science and machine learning to statistical tools like tidyverse and SQL for learners of all levels from beginning to expert. We then organize also career events, industry sharings for students' professional development and endeavors. So I think we had one last semester on from a guy from Alibaba, and then during the summer break we had a Dr. Koo from Data Science SG who shared a little bit on some tips and tricks for interns coming into data. So you can join our statistics and data science community today by following us on all these different channels. I think you can find us on Instagram with NUSSDS, and our Telegram is here at tinyurl.com/statstally. Yeah. So I'll leave this for about another 30 seconds, and then I'll move on to the main meat of the content. Let me see. This is yeah, and we may have a mini recruitment drive in semester 2. This current sharing is to you, such that you can understand and know more about our activities and what we do to be able to benefit from what we have to offer to you, the student body. Okay, so let's start on with the workshop then. So for the general NUS freshman just coming into the field, you may wonder to yourself, what is the big picture? Why is exploratory data analysis so important? We need to first have an understanding of the overall goals and uses of exploratory data analysis in the data science pipeline in order to understand what it is we want to do and how we can achieve it. So a bit about data scientists in general. Data scientists work in a very dynamic and multidisciplinary field where problems we want to solve are extremely varied in different forms and mediums with vastly different use cases and requirements. However, at the heart of every data scientist problem is data. We need to understand our data, how it flows, patterns in the data set, some unique structures within our data we can exploit, perform our tasks. This is hence the foundational bedrock of data science in general, following which some actions might follow that one might consider applying. So some possible actions one might take following a round of exploratory data analysis could be first to start cleaning the data, which involves deeper and more understanding of the data, finding outliers, scripting functions to clean the data set, to represent what you want to predict. Another sometimes overlooked action to take following exploratory data analysis is to determine the quality of the data set you're using and to determine whether you need to collect more data or to build more infrastructure to facilitate this pipeline for the data to use. In fact, exploratory data analysis can be itself an outcome through asking questions of the data set as a whole, finding insights. And for example, if you're looking at customer data, you can make observations and trends on this data for business insight. Following up from this, the data set could be used to build dashboards and visualizations to communicate the ideas, these data-driven insights to non-technical staff and apply actions that can capitalize on these insights. And lastly, if our goal was to perform a prediction task, then I could follow up this EDA with implementing or calling a suitable machine learning model to apply a prediction task on. So these are the 3 main routes that one could take up following exploratory data analysis with, but of course, there are many other ways you can go, and it's non-exhaustive. A side note is that each of these 3 actions itself deserve workshops and are critical skills to a career in data science as well. We do have some past workshops on these topics that you can check out on our website. Now, moving on, let's look at some concepts and techniques used in exploratory data analysis, particularly for tabular and numerical data, as this is the most simple to visualize and understand. So once again, you can ask us anything at this pigeonhole. Now, on to the main topic, we need to understand some statistical tools, metrics, and questions to ask ourselves in order to learn more about our data. Tabular data usually consists of numerical, categorical, as well as time series data. So numerical data is a numerical column that could be an integer, decimal, some percentage data, and so on. This numerical data can also be thought of as a continuous random variable in statistics. Such values can follow statistical distributions like the normal distribution, which you might be familiar from A levels, and have outliers that can be seen through estimating these data points with these distributions. Nothing much else more special about these data until you compose them together with other values and that can form pictures, encodings, or generate insights through statistical metrics. Categorical data. Now, categorical data is understood with the analogy of perhaps a fruit. In our data set, a fruit can either be an apple or an orange. Hence, in this data, categorical data can be thought of as a discrete random variable where the domain is either an apple or an orange. And lastly, we have time series data. That is data that is pegged to a timestamp or interval of time. Time series data can be thought of with the analogy of a stock. Let's say Tesla's price. Over a given time period, is characterized as a sequence of data points successively taken at space points in time data. Now, each type of tabular data has unique and interesting methods that are employed to better understand it. So far, is everybody okay with this? Let me just check our pigeonhole link to see. Yeah, okay. Seems like we are good there. In that case, let's move on. So, most data appears to follow a normal distribution, which is generally due to the central limit theorem, which in probability theory states that in situations where a random variable is sampled over and over, the normalized sum of the variables tend towards a normal distribution, even if the original variables in the cells are not normally distributed. Now, this is a very powerful observation that allows us to have a standard way to fit data points. So let's take a look at this normal distribution and see what's so useful about it. A fun fact is that normal distributions are also known as bell curves due to its bell-like shape. And that's also perhaps the common idea of praying to the bell curve god comes from. And I hope you can be on the right side of the bell curve too in your time here. So firstly, to define the theoretical normal distribution, it's centered on a mean. So this mean, denoted by this symbol, and is symmetrically spread around on both ends, such that the area under the curve on the left equals 0.5 and equals to the area under the curve on the right. Hence, this whole curve, the area under it, or the integral, sums to 1, as probability can never be more than 1. If we have more than one probability of more than 1, then we don't know what's actually going on, do we? Yeah. So variance. Variance is the spread of the data around the mean. So how far, how much can the values vary? The median is the middle value of the data set, and then the mode is also the most frequently occurring value. This will be more concrete later on. So then in reality, does most numerical data exactly follow a normal distribution? As with all things in life, things are much more complicated. Data can follow a normal distribution, but may have imbalances in the data set, perhaps due to the upper or lower bounds of the columns. Like for example, test scores. This leads to skewedness in the data, which indicates that one might want to apply tools to handle it, as a prediction may take parts of the data set as outliers due to this skewedness. Such patterns can be resolved through the use of data transformations, for example, a log transformation. For more details about this, you may read this article later on or find out more on Medium or other such blogging sites where you can find a lot of open source information about this. And so a little bit about skewedness. So when the mean is less than the median, less than the mode, you get a negative skew. Then positive skew is when the mode is less, oh wait, oh, oops. I think I forgot to change this. Yeah, but moving on. So categorical data. Categorical data can be best explored and understood through charts and diagrams or tables. Numerical columns can be turned into categorical columns as well by labeling them according to number ranges. For example, exam scores from 0 to 49 being a fail and 50, 100 as a pass. So these are some ways to do what is called binarization. Another way of understanding categorical data comes through viewing different subsets of numerical columns of the same data set using different metrics. For example, this swarm plot here visualizes the distribution of sales prices for males and females over a time period of Thursday to Sunday. Some interesting preliminary observations we can already make is that females seem to shop more on the weekends, while males seem to shop more on the weekends. More than females tend to shop more on the weekdays, and males tend to shop more on the weekends. And also that Friday, people seem to be shopping a lot less. There's already a lot of interesting information encapsulated, understood from this singular diagram. Okay, let's have a bit of a short break before we move on to the pandas functionalities. So you can ask us anything here, and I'll move over to the pigeonhole and look at the chat to answer any queries you'll have. Okay, let's take a look at oh, what happened here? Okay. Yeah. I think then we'll just have like maybe a 1 or 2 minute break. Then we'll move on. Yeah. So far, do you have any questions? You can on your mic and ask directly, and I really welcome that if you like. Yeah. Patricia?
Stephen, I think there's a question on the pigeonhole.
Oh, okay, great.
Yes, it's about how to tackle right skewness. That one, yes.
Do you have an idea of that? Actually, I didn't look into that one. Well, I don't know specifically, but maybe I can show you how when we have a question that we don't know, how can we answer that? Drew, let me Google that for you.
It's a good question. We'll all learn together.
How to handle right skew. So these are some of the methods you can use. So you can just Google it. Usually you'll get like a good article or something where you can read up on these things. So let's take a look here. Okay, so this is just like that. So log transformation is apparently the first thing you do to do that. Oh, square root transform. I think what they mean is like you can just try out a few different measures because we don't know specifically what would solve and make the skewedness be resolved. So we try different measures. So the most common one is the log transformation. Then we have the square root transformation that could solve that. And then this Box-Cox transformation. Yeah, I think this is an article that maybe you could look into. Yes, but this is for right. Yeah. Any other questions? Okay, for time.
Yes, there's one. Yeah.
Okay. Is there only desired value / time, or are there other graph types for it? time series, is there only desired values over time, or there are other graph types for that? For time series, we can, we can do aggregations as well. So like we aggregate perhaps, let's say we have sales data. So we want to aggregate on like maybe on Mondays to Fridays, then see do the mean of that, like do people buy more items on Sundays or Mondays or Tuesdays or whatever. So these are some other ways we can look at it other than just looking at it sequentially in the time versus y-axis kind of column. Yeah, so I think that's one such way. Another way is that we can ask questions about it. We can look into seasonality, which I think is more so related to this one. So where we are looking at desired value versus time itself. So we're looking at like maybe in a certain, let's say for a stock price, maybe there's a certain like kind of time interval window that seems to go down at, like how I say, that the stock price seems to hit a peak, then hit a trough, then suddenly like go back to a reasonable value, a sinusoidal kind of thing. So like where it goes down, up, and maybe it has a general trend of going up, but we don't but we see that there's a general time frame where it seems to happen. Yeah. Okay, so I think we can move on from the break time then. So we'll be talking a little about pandas, one of the most widely used data manipulation libraries in all of data science, particularly in Python. Yeah. So I'll be going through some simple functionalities in pandas and functionalities that you may see later on in the hands-on portion. So let's first start with reading in data from a given CSV or comma separated values file. So what is a comma separated values file? That's a Excel file. It's essentially something like an Excel sheet, which you have, but it's generic, such that you don't need to follow like Microsoft's file format, their encodings and whatnot. And it's a standard format that's used in a lot of data science stuff and a lot of data storage stuff also. So we demonstrate this very simple line you can use right off the bat in a Google Colab notebook. So you may ask then, what's a Google Colab notebook? It's essentially a very easy way to run Python code without needing to install anything on your computer. You need a Google account, of course, but you are essentially reading and passing this CSV file into pandas to read and ingest this data into a data frame. So then what's a data frame? So now we have ingested a CSV or a Excel file into this thing called a data frame. So what is this data frame? A data frame of pandas is essentially a collection of key value pairings of columns, labels to rows. And this is the main object and workhorse of the pandas library. As such, almost all functionalities of pandas hinge on this data frame or singular columns of this data. Now, let's take a look at this diagram to better understand a data frame, kindly provided from Geeks for Geeks. That's a good website for you to find out a lot of stuff, not just for data science, but programming in general. So you can see each one of these is termed as a series. So one column of rows of how I say index rows and data is called a series. So each series has a different data type. So what's a data type? A data type is essentially the kind of value that is being used. In this case, it's a string value, or rather just a word. Other values can be floats or numerical values. It can be decimal pointed, or it can be just intervals. I think in this case, they don't have a integer, but yes, these are some of the ways you do. Each row of data is also indexed by a label, right? A label. So this label of the index is 1, but it also has a different label in terms of Pythonic label. This will be more clear later on as well. So values within the data set have varied data types and consist of also missing data or invalid data types called NANs. And you may need to transform these into usable values or drop the rows that contain NANs in order to perform whatever task you want. Now, moving on, this will be quite a brief kind of introduction because there'll be a much more in-depth one by Rui-En in a while. So indexing rows, there are three main methods in general. Firstly, to index on the data frame itself by doing this :2, or you can index on the index value itself. So index value meaning you start from an index of 0 to 2. So you get 0 to 1, and then you don't get 2 because it's 0 index. So if 0 indexing comes from, I think, the predecessor of Python, which is C coding, where the values you have in a list of items starts from the index of 0. So you have 0, 1, and then 2, but then you don't access 2. However, if you index on the row label itself, then you're indexing by this .loc, where you're indexing from what's implied to be 0 up till 2. So you're getting this label 0, 1, 2. Next, you can also access series data and subsets of the data set of the data frame by either using the column values or by index values. So if you want to access just one series, you access longitude and you wouldn't have latitude here. Yes, while if you want to access by index value itself, you need to take note of the index location that the data is displayed in and access it using this iloc, where you use this colon to represent that you want all the data from 0 to n, and then indexing on the columns itself. So meaning by the column labels. Yeah, now moving on. What are some ways you can define pandas data frames from raw Python objects? We can use a dictionary of lists. So what's a dictionary? A dictionary is essentially a key value mapping. So from, like, let's say apple to 1, something like that, where pandas will take keys as a label. We can also specify the data type of our rows and columns. For example, in this case, float. Now, in this case, we only have one applicable data type for this float. So only this one, which is an integer value, will be typecasted to a float. A float meaning it's a decimal pointed value. While these ones are invalid to be applied this data type, and therefore we simply define them as objects, or in some instances, they'll be just called strings. Lastly, we can also define it through using a data frame from a two-dimensional list, where these are all determined as rows. So from 0 to 3, then we define the columns for them directly. Now, we also need to do filtering. Filtering has always been an important part of exploratory data analysis, and that's no different here. We can use the data frame itself to filter, as well as the query function in pandas. The difference being is that we use bitwise operators in the data frame, and contrastingly use the word form in the query function. So like in this case, we are using the n. So we want where the longitude is less than -122, and the latitude is greater than 35. Using the query function, we do not equals. So where the longitude is not equivalent to this value, and where the latitude is equivalent to 35. And then we can also negate a condition. This is the operative route of the query itself. For example, in this case, we want to filter houses by a longitude of less than 122. Then the requirements change, and now we need to explore the opposite case. That is, the longitude is longer. This also holds more complex Boolean cases involving the AND and OR gates as well. I think the OR gate is the line, like where your backslash is. When you press shift and you press that line, it'll show you a line. So that's an OR. So now we also need to handle NAND data. Not a number data. It's important Like handling this is important to fit your data to work with any machine learning model. It can be as simple as replacing the NaN values with a NaN equivalent encoding, or by simply dropping such columns. However, cleaning such data is important to get meaningful insights into a dataset. Hence, here's a method to check some of the number of NaNs in your different columns, which can help determine the way you may want to handle it. So, right off the bat, the simplest idea that you could use is to just drop the row, as we can't use it directly. However, we may be ignoring details that may be present within the dataset. For example, if a person had a Tesla, he may also have had an electric charging dock. And if he doesn't have a Tesla, he will also not have a charging dock for the car. So there are some conditional implicit values involved as well. There are interactions that may make NaN columns actually contain some useful information that can be transformed in order to become useful data. This could be used by perhaps in one-hot encodings that is taking different unique values in a row and expanding the data by using each individual value. For example, fruit, apple, orange. So is there an apple? Then there'll be one column. And then is there orange? There'll be another column. And then we'll essentially create new rows from that singular categorical row. We can also utilize imputation techniques, like filling missing values with the mean value, or by propagating non-NaN data values forward. Alternatively, we could also perform interpolation on the data if there is an inherent sequence structure to the dataset that could be exploited. So this would be like drawing a line from yesterday to 2 weeks from now, or something like that. Now, moving on, feature engineering. It's another component of EDA, but also deserves its own mentioning. So we will not be going through in depth. Instead, I'll focus on some of the different methods that you could think of to create new columns from original values. We can directly apply numerical operations upon the data frame itself to each row in a vectorized manner, applying it across the entire column. This can be useful when we apply an equation. For example, price times quantity equals revenue. Next, let's talk a little about aggregations. Aggregations is where we group the data frame according to certain criteria. That could be a binarization of numerical columns, categories themselves like apples and oranges, or time intervals, or a combination of such different row values themselves. Then we return a group aggregation value, such as a maximum, minimum, mode, median, sum, or some other different operation. So we can also iterate through the different rows of the data frame, and this can be a very useful way to access rows for feature engineering customized features that may require perhaps multiple states to be tracked across time. Alternatively to vectorizing on the data frame, as we saw previously, here, this is vectorized on each row. We can also apply lambda functions or anonymous functions in order to iteratively apply an operation row-wise. So for example, here, I'm applying a string transformation on the longitude value and the row's latitude value to create this coordinate string. So we can also do a little bit of data visualization in Pandas itself. So it's rather limited, but it's a useful feature that we can use to spend less time on transforming rows to plot with Matplotlib itself, and to just use a simple interface and to just specify the column values, X and Y values, as well as the type of graph itself that we want to plot. You may check out this article or on a detailed guide for this Pandas functionality specifically, or check out on the powerful Matplotlib library as shown over here later. So now let's take another short break before we proceed with the code along. So I'll answer any questions. Okay, so Yang Chao Lin asks, is there a link for sign up or to know more? So you can know more about us by following us on our Telegram, Instagram, or just follow our Linktree. Linktree So from our link tree, you can see our website where we have our past workshops, which has a bunch of different articles that we've written, and also look at our previous workshops as well. We have some different events. I think we have recordings also of these events. Yeah, we post them up on our YouTube apparently. And we have a lot of different things. So if, about us, our different articles, and a bunch of our workshops. Yeah. Yeah. Okay, let me go to the pigeonhole.
Before that, one thing to note is that our workshops are all available to the public, so you do not have to be a member to participate in them. And also, if you are interested to join our community, our recruitment actually happens in the summer break. So our recruitment for this year has ended, but do not worry. You can just join the Telegram group and you can possibly join next year. Yeah, our recruitment cycle is a bit off-peak, so do take note of that. And do not worry, you can just join our workshops for this year if you're not in the community, because we will deliver to you nice content for you to learn stuff. Yeah. I think now we can move on to the pigeonhole. Yeah.
Yeah. Anything else? Seems like not.
Yeah, no new questions, I think.
Okay. In that case, we just if you all have any questions or whatever, you can either post them in the chat now, or you can speak up and ask us directly. Ask us directly, please. Like I also prefer having a conversation than answering the chat. Yeah.
So the workflow for this this workshop is basically after we go through the slides for pandas, NumPy, and we will move on to the code along session at the end. So do stay on and follow us throughout the workshop, because you can get to practice the skills.
Brian, maybe I can stop my screen share and then you can continue on your side. Yeah.
Okay.
Okay.
Now we have reached the code along session of this workshop. So now we're going to start do the practical component for the Python workshop, so we can understand the concepts. Okay, so in this code along segment, we will be covering 3 parts. So we will practice how to use pandas and how to use a data frame. And we will move on to NumPy, where we will learn how to calculate statistics. So we have learned mean, mode, median, and variance previously. So we will learn how to actually calculate those statistics. And the final part of the code along includes the data cleaning part. So we will learn how to handle missing values. There are actually a lot of different data cleaning segments. You can handle duplicate values as well, and many other data cleaning things. But for now, for this workshop, we will only learn how to handle missing values. So there will be lots of practice questions, and we will go through them. So if you want to encounter any difficulties, feel free to ask in the pigeonhole link. So this is the Google Colab link, and it is called basically tiny URL NUSSDS SLF hands-on. And the slides and the code along solutions will be released to you at the end of this session. So have fun learning, and I think now we can just, if it's not sent yet, check out.
Yeah.
So now let's just enter the Google Colab link that I have just sent. And this link will lead you to the hands-on part where we were going to perform some operations in Google Colab.
We'll provide solutions at the end. Yeah.
Yeah. So basically just click on the hands-on and what you may get to see is this. And it looks very weird, right? But do not worry. All you have to do is to just press open with Google Collaboratory. But okay, actually, right, we shouldn't use this link. We should use the please use this link. Okay. Is everything okay now? Does anyone have any problems opening it? Okay, just
There's
hold
someone
on
who
for a
can't
second.
access it.
Okay, I realized that there was an issue earlier. Let me just send a new link for you. Are you able to access the new link? Okay, great. Great. Okay, so now this may be what you see when you first open the link, and it looks like Greek, right? Like don't know what's going on. So just actually open with Google Collaboratory. You should be able to see it at the top of the screen, and once you open with it, you will get to see a nicer view of the page. So let's just wait for it to load. Why is it not loading? Okay, please just give me a short while. Okay, okay, I think there are basically two different links that could be used, and you could try either of them. I'm not sure why they don't work. Okay, so I will just send a new message. So the first link is the original link that I sent, and by right it should work. I'm not sure why it doesn't work. And the next one is the Drive link that I sent, and so you could try either of them, and hopefully they work. And if they do not work, maybe you can open in incognito mode because it worked for me. Yeah. Okay, so does anyone have any errors? Is it okay? Is everything okay now? Is everyone able to see this page? If you're able to see this page, please respond with by saying yes, or you can respond with an emote. Yeah. Yes, okay. Everything is all right now. That's great. Okay, so let's begin with the code along. Okay, so this is a hands-on section, and in this code along, this file does not allow you to make changes because it is a playground. So playground means that it's only a read-only file. So what you can do is to just press copy to Drive, and you will make a copy of this where you can actually just, okay, I'm using incognito here. I got it. Okay, I'll use this. Okay, this should work now. Yeah. Let me just reshare. Apologies for the technical difficulties. Yeah. Okay, let me just reshare again. So sorry. So once you press copy to Drive, you should be able to get a copy of hands-on, and that is where you can start to you can try making like some changes to it, and if it works, yeah, you should be able to make changes to it after making a copy of it. Okay, does anyone have any problems making a copy? And I think I'll just start now. Okay, so this is Google Colab, and firstly, Google Colab is also called collaboratory for the full term, and it allows you to execute Python in a browser. So there's zero configuration needed. You don't have to download any Python language or like any Python packages. All of them are here. All you need to do is to just write an import statement, and there's easy sharing via Google Drive. So it is possible for you to do online collaboration here. And it is free, but there is a limited access to GPUs. So GPU is better than CPU, and it allows you to run code much faster. It is usually used when you do machine learning. So, but in this case, we are just using simple code, so CPU is enough. But this is just good knowledge. Okay, so this is just some background information. Google Colab is actually a hosted Jupyter Notebook service. Jupyter Notebook is also similar to Google Colab, except that it is not online, so you do it on your local computer. And we can just move on to the next part where we explore the layout of this notebook. So this is in the file tab, you can see the usual file functions, like you can save a copy in Drive, can rename and move to trash, etc. And in the next tab, in the edit tab, it allows you to select all the cells, or you can cut, copy, and paste. You can even find things. And under view, there is not much for you to know here. Insert is where you can insert a code cell or the text cell, and I will explain this later on. And runtime is important because it shows you quite a lot of different ways where you can run the cells. You can choose to run all the cells, or you can run all the cells before the current cells, etc. And now we have the tools palette. This is where you can, just press settings, and you can also do some keyboard shortcuts. So I will cover that later. And one important function of this notebook is that you can press this and you can see the table of contents. So I have actually made it such that there are different sections for you to easily navigate to. But let's just close this and follow along with the session. Okay. So this collab notebook contains a list of cells. There are two cell types, a code cell and a text cell. So notice that when I press this, there is actually a container-like looking box. So this is one cell. And in this case, this is a text cell. So if I were to double click on it, it will actually show something like this. Okay, I think I've messed up. This is actually a code cell. Yeah, this is a text cell and it contains the text in Markdown language. Yeah, so this is something called Markdown language, and it's something that allows you to type text in an easy way. And code cell is something like this, where you can create a 1+1, and then it will lead you to it can allow you to output your code. So yeah, so let's move on, and you can view all the shortcuts. And so now let's go on to the shortcuts where you can learn how to code more easily. So to edit a cell, all you need to do is to just press enter on your keyboard, or you can double click the cell. So if I were to press enter here, it will show the Markdown language. And it is not important, it's not covered in this workshop, but this is just something good to know. And if you were to view the cell by pressing escape and click another cell, you can just undo what I have just done. So simple, you can just press enter to edit and press escape to stop editing. And you can run a cell by pressing Control Enter. So you can only run cells that are code cells. So because there's nothing much for you to run if it's a text cell. And if you can also create a cell above by just hovering over the top of a cell and pressing a code cell or text cell. And you can also delete a cell or undo cell level action. But most importantly, what you should know is to know how to edit and view the cell and run the cell. So all the cells are created as code cells by default, and you can switch between code cell and text cell as follows. So this is just so you see, as I create a new cell, it is created as a code cell by default, and I could type 1+1 and run it. But if I were to change it into a text cell, all I need to do is to just press Ctrl and M, and it will become a text cell. And when I press enter to edit it, it is actually a text. I can just hover over it and press bold and press escape to view it, and it's bolded. So this is a text cell. And if I were to just type Ctrl and Y again, it will go back to a code cell where I can run it. So lastly, you can view all the shortcuts by just pressing Ctrl and H, or you can go to Tools and press Keyboard Shortcuts here. So there are actually a lot of shortcuts for you to explore, but I only chose the more important ones. So now let's do a very, very simple exercise where you can just print Hello World, because that's what we always do when we learn a new language here. So just try to navigate to the cell below. If you're using a keyboard, you can just press down, go there, or you can just use a mouse to click on it. And when you want to edit it, you can either double click it or you can press enter. So now you can start editing it and just type print Hello World. And after you're done, you can either press Control, Enter, or you can press this Run button to run your code. So far, any questions? Okay, no more questions. No questions for now. Yeah. So I think we can just move on to pandas. So firstly, let's import the pandas library. So you just need to press Run here, because if you don't press Run here, the subsequent ones would not know what is pandas, and they will throw an error. So we can move on to the next section where we create a data frame. So there are two ways of creating data frame. In actual fact, there are more than two ways, but here we will just cover two ways. So you can either create them column by column, or you can create them row by row. And we will actually use two different data types here. So if you were to create them column by column, we are using something called a dictionary. And row by row, we will be using a list. And then we will convert this data type into data frame. So we can just look at this example here. Here we are creating it column by column. So you can see for every line here, it actually translates to a column here. So we have name and Adam and Mary like this. And we have 3 lines here, so it corresponds to 3 columns. And here we are using a dictionary. So dictionary actually contains mappings. So it's for example, you could map a name called an apple to a number called 1. So whenever you query, you find apple, you will get 1. It's just a mapping or like a pairing per se. And here we are pairing a string. So this is a string. String is basically a text to a list of strings here. And here we are pairing a string to a list of numbers. And this is a Boolean. So Boolean is basically true or false. And then we will convert the dictionary into a data frame. So it is very easy. Just need to call PD. PD is pandas and PD.dataFrame. And once we run df1, we will get this as an output. So actually for this, you just need to understand the syntax. It basically one line is 1 column, and just convert it into a data frame, and that's it. So we can just move on to the next way, which is to create them row by row. So we are actually using the list data type, and it is 2 dimensions. So basically, there are many lists inside this large list. So you can see that here we have 1 large list, and inside we have 2 small lists. And each list corresponds to 1 row here. So we have Adam 95 true, and similarly we have Adam 95 true under the first row. And then we will convert it into a data frame. And we just have 1 extra step here where we just need to type the columns. And for example, if I were to change something like, have you passed here? And I run it, then you can see that it's changed here. So one question that you may have is that a data frame looks like a table, right? It looks like a table, like what you see in Excel or something. So is data frame a table? But the answer is, despite sharing a similar tabular look, they are defined as different data structures. So a data frame is not a table. It is incorrect to call it a table. Data frames have more advanced operations and manipulations than what you see in Excel or even SQL if you have used it. And the creators of pandas have actually focused on making it run faster across a larger output. So to summarize this, just need to know that a data frame is not a table, so do not call it a table. So here we have explored how we can create a data frame from, data that you came up yourself. But what if you already have existing data? So for example, you already have an Excel sheet full of data, and you just want to convert it into a data frame. So what you can do is to just use pandas read something something. So what do I mean by something something? Pandas has a lot of functions that allow you to read data from existing data. So the most common function is read CSV. CSV, it stands for comma separated value, and it's also available in Excel. And basically, if you want to look at, if you have a CSV file, you can just run read underscore CSV, and it will translate it into a data frame. So here we got the data online as an Excel file, and this will update daily. So the data frame will vary based on when you read it. This is a COVID-19 data set, and you can see that the data set ranges from 23 January all the way to 9 August, which is just 2 days ago. And as you run, and this will just update every day. So maybe tomorrow you will see 10 August. And you can see that the daily confirmed, daily discharged, basically the COVID data set. So this is just a very simple function for you to just type df.head, and it will read the first 5 rows by default. So maybe sometimes you don't want to read the whole data frame because the output is actually really large here. So you can just run df.head and just have a simple snippet of the data frame. So the data frame may look a bit confusing for you at the start, but it's okay. We can slowly understand it together. So this is obtained from Geek4Geek. It's a website online that focuses on computing things. We can just study how the data frame components look like. So we have the column names on top, and index don't really have a name, but they have labels instead. So by default, the labels are just 0, 1, 2, 3, 4, 5, 6. And we have the listing values if they're like nans, and these are the data. So you can just look at this data frame and just try to identify the components. And the very important thing to note in data frame is that it has 0 indexing. So what does it mean? It means that instead of calling this column as column 1, we call it column 0. So we have column 0, column 1, 2, 3, and column 0, 1, 2, 3. So they all start from column, and this all start from 0, which is why we call it 0 indexing. So now let's try to get the rows of the data set. And why do we want to do that? Because sometimes we only want to read the specific entries of data instead of reading the entire data set. We can get the specific rows by using these, either the label value or the index value. Basically, the label value is just what you see here. This blue box here and this purple box here, they are all label values. And by default, the label values for rows are in numbers, so 0, 1, 2, 3, 4, 5, 6. And you can actually change those labels to words even. And here we have the column names, and they are the labels by default. So there are 2 ways of getting the data, which is, first way is to use the label value. And we can just explore how it works right now, because so df.loc just means that LOC just means that you can get data through the label value, while ILOC means that you can get data from an index value. So if you want to get one element, you can just put one number here. So the reason why I wrote 0 here is to just get the first row. So 0 stands for the first row or column. And you can get 2 elements, or you can get a range of elements. So you can get from the first row to the 4th row, and we can have the 5th row, and here we can get the first 5 elements as well. So just to do a demonstration, if you want to do df.loc, okay. So the reason why it didn't work is that it's because I did not run it here. So after I run it, the program will understand what is DF. Previously, it did not work because it did not know what DF is. So if I were to run it now, it will just show the first column. And the first column is the, okay, it will show the first row, I mean. So this will show the first entry where you can see the daily confirmed false positives found. And it corresponds to what we see here. Yeah. So this is the row for 23rd January. And you can see that it also shows the data for 23rd January. And we can also search for multiple rows by just typing 0, 4. So this will show you 2 different rows. So this is for 23rd January and 27th January. And you can get a range of elements by just typing 0 to 4. And you will see that there are everything from 23rd January to 27th January is listed down. And you can also do the first 5 elements by just typing like this. So just another reminder, we wrote 4 here instead of 5 because the indexing starts from 0, which means that you will count from 0, like 0, 1, 2, 3, 4. Even though this is actually the 5th column, if you were to, just count it as 1, 2, 3, 4, 5. Yeah. And one thing to note that index value is the way we use index value is the same as the way we use label value. So you can see that they all look the same, 0, 0, 0, 4. But when it comes to getting a range of elements, we need to add one more value to the ending index because ILOC will exclude the ending index. So if we were to do an ILOC here, instead of getting 5 rows, we will only get 4 rows because it will exclude the 5th row, which is the last one. So let's just try to do some exercise and try to get the 2nd row and the 4th row. In the meanwhile, I will check for any questions while you can work on this exercise.
Yeah, I guess we can answer maybe on the society stuff or whatever. What's the difference between SDS and other societies also focus on programming? You can go to the, okay, I hope you all can't hear that, but okay, so what's the difference in SDS and other societies focus on programming? So the difference is the target audience, right? So statistics and data science society, we focus on servicing the data science community. People are interested in a bit more mathematics. So we're not delving so much into like optimizing algorithms, algorithmic complexity and whatnot. Our focus is on data science, deploying data science models perhaps. And so like that will be kind of the main scope of our work. So we are focusing on the data science and science community of NUS rather than on computer science, although there will be some overlaps as well. So I think that answers your question. Yeah. Yeah. And another one is, are we still recruiting? Not for this semester. However, you can look out on our relevant social medias and Telegram group, particularly for all our updates on our events and whatnot. We may have a mini recruitment drive in semester 2, and our Telegram group will constantly update about new events and workshops, so you can attend them and be a part of our society as well. So random number asks, what's the difference between this and NUS FinTech Society? Well, we are focused on data science in general, while I think FinTech Society, they might delve into like blockchain or like other parts of finance, because FinTech itself encompasses not very much. Okay, there's some overlap in terms of quantitative finance, but apart from that part, they delve more into like financial technology, transactions, investments, and whatnot, more so than us, which is focused on core on data science itself. So data science can be applied to finance, but finance is their main focus. Yeah.
Okay, I think I can start, can move on. And so now let's try to get the second row and the fourth row. To do this, there are two ways. So we can either use LOC or ILOC. So we can just type LOC. And now we will put another list inside because this is just to show that you need another list if you are having more than one row. So if I were to just type 1 here, it will get the second row, which is 24 January. And if I want the fourth row, I will type this. And here we got the 24 January and 26 January records. So if you actually type 2 and 4, please revise on what I said previously about zero indexing. So you count from 0. The second row is the first row in that sense, and the fourth row is the third row in that way. And now let's do the second exercise. I will just go through. So we can try to get the first 4 rows. And the way you can do it is to just type df.loc and you can just type 4. But if you were to type 4, it will actually get the first 5 rows because of the zero indexing again. So what you can do is to just type this. And there you go, you got the first 4 rows. But remember, there's also another way for you to do things. You can also work on it using ILOC. So if I were to go back to the previous exercise and I type ILOC, you can also type 1, 3, which is basically the same as the one above, and you will get the same result. 1, 3, 1, 3. But when it comes to getting a range of results, ILOC is different from LOC. You will just need to add 1 at the back. So instead of 3, you have to type 4. And you will get the same result. And now let's move on to the columns of the data set. So it is similar to what we have learned previously, just that the syntax is a bit different. You see that there's a colon in front, and that's basically about it. And one more thing is that the label value are no longer integers, because you notice that the column names, they are in strings. So you will have like a date as a label instead of 0. And yeah. So this is how you can do it. And let me just do a simple code along, just show you. So if I were to type LOC dates, it will basically just get the column for the dates. And here you see lots of dates. And there's actually a simplified way of getting columns using the label value. You can just easily delete all these and just type this, and you will get the same result. So you can also get multiple columns by having another list inside and typing the daily confirmed. No. And you will have 2 columns here. So instead of type the longer form is to just type df.loc with a colon, comma, and date.daily discharge, but it's really not necessary. Just learn how to use the simplified way. And yeah, we can also have a range of elements by just typing df.loc date daily discharge. And then you will get everything from dates column to the daily discharge column. Okay, so I'll just move on. And now we can actually just try to do it ourselves before I go through later on. So the first exercise is to get the daily confirmed value via its label value. which means you're getting it using the name. So it's actually really simple. DF, and then you just type daily confirm inside. And we will get the column for daily confirm. Simple. And then we can move on. We can also, the next exercise is also very simple. You just need to get two columns, the daily confirm column and the daily discharge column, using that index value. So I'll just give you maybe 2 minutes or 1 minute to try to do it on your own. When in doubt, just look at the table above. Okay, I will actually just go through now because it's really straightforward. So from this question, you'll notice that there's more than one column, right? So you can actually just look at this part where it talks about getting 2 elements. And you can just follow this, or you can follow the simplified way. But you have to use the index value. So index value does not have a simplified way for now. You can just, follow this syntax and you can run it. And you will get, okay, so this will actually get you the date and daily discharge column. But if you want a daily confirm column, you just need to change 0 to 1, and there you go. So now we can just move on to the next part where you learn how to filter the data. Filtering data is also fairly straightforward, and you just need to make sure that you are clear with the conditions that you want. So because the importance of filtering data is pretty high, because not all entries may contain the information that you are looking for. You may only want to get the rows that fulfill a certain set of conditions. So if you only have one condition to do, you just need to type inside this large bracket and type a condition here. But if you have multiple conditions, you can add a bracket and add a condition inside, and add a column. This is an AND, which means that you need to satisfy both the conditions, and add your second condition here. So let's just do the exercise together. You can get the rows of the days where there are more than 100 daily confirmed cases. And notice that there's only one condition here, which is more than 100 daily confirmed cases. So all we can do is to just type DF daily confirm and type this. So this just means more than. Run it. And in this data frame that we got, you'll notice that the daily confirmed cases, they're all more than 100. So it's pretty serious. Okay, it's not as serious, but we can just change the numbers as you wish. More than 200, or even more than 1,000 if there's any. Okay, these are pretty bad days. And it's probably during the near circuit breaker period. So moving on to the next exercise, we can get the rows, but there are more than 100 daily confirmed cases during the circuit breaker phase. So notice that there are 2 conditions here. So more than 100 daily confirmed cases, and it is during the circuit breaker phase. So what we can do is to just type DF, and we have just gotten a condition from earlier. So this is one condition. We can put it in brackets just to make it clear. And we can do an and add another bracket. So you can just type phase and make sure that it is equals to circuit breaker. when we run this, the resulting data frame will only result in, okay, it should be 100 instead of 1000. And yes, the resulting data frame will show a daily confirm of more than 100. And if you were to go to the right, you can see that the phase, they are all in the circuit breaker phase. So now, let me just check if there are any questions. Okay, I think we can just move on from here. Okay, this is an extra exercise. The solutions will be uploaded soon, and you can see if you have time after this workshop. So now, after learning how to filter the data, we can try to apply the data. So we can manipulate the existing columns to get a new column that has information that you are looking for. So it's very simple. We can just do we can name our new column here. So here I'm naming a new column, net daily confirm. And I'm manipulating the existing column by just subtracting this from this. And the resulting data frame will contain an extra column. All you have to do is to just go all the way to the right, and you will see a new column here, net daily confirm. And it will just contain the information that, it will just do a simple subtraction of these columns. So what you can do now is to do a very simple to-do exercise. And you have to calculate the percentage of vaccinated Singaporeans against the entire population of Singapore. So you know how the government have been saying that we have reached 60% of the population being vaccinated, etc. So this is something that you can just do to track what is the exact vaccination rate. So you just a guide before you actually start. So you can type any name that you want to name. So like a new column, and you have to do something to the two columns. To this one column called cumulative individuals vaccination completed. So I'll just give you maybe 1 minute, 2 minutes to just try this out. So just one hint for this exercise, you just need to use a division operator and a multiplication operator to calculate the percentage. So you'll be using a divide and a times. Okay, so I think I will just go through now. So what you have to do is to get to do this. So we will manipulate this column, which is why we will type it here. And we will divide it up against the entire population of Singapore, which is this. So just copy this. So you divide it and multiply by 100. So that is how you get the percentage. And you may want to rename it to something like percentage vaccinated and run it. And then you have to type df again to just view the data frame. So this is a new data frame that should contain the column percentage vaccinated. And you'll notice that some of them, they have none values. So this is something that we will cover later on. And yeah. Okay, wait, this is a bit different. me just check if there are any errors. Um, okay, I realized the issue. So there's actually one more zero should be added here. And yeah, because this is more correct. It represents that Singapore has 5.9 million residents. Apologies for that. So if you were to do that, you will get a more accurate percentage vaccinated. So you will see that this is 62%, 63%, 64%, 65%. And yes, that is correct. So now we can also learn how to apply functions to the data frame using df.apply. And we won't be doing any exercises for this. So this is just read through. And here we are initializing a simple data frame. And we can increment all the values by one by using something called a lambda function. And basically it will just iterate through all the values and add them by one. And so from 1 to 3, you will get 2, 3, 4. And then you can also square all values by doing this. So here, instead of doing lambda function, which could be quite complicated if you're not familiar with it, you can define your own function like this, and then you can call it here after using the dot apply. And then go from 1 to 3, you'll get 1, 4, 9. And let's move on to the next section where you can analyze the data. So this is a very simple data analysis where you can just do df.describe. And it produces all the statistics for you. So you can see the mean, the standard deviation, the minimum number, and the box plot statistics here. And all you can do is to just try to analyze an attribute that is of a numerical type. So from the slides earlier, you should have learned what is a numerical, categorical, and time series type. And all you can do is to just type something like this. So you can get an attribute that is of numerical type. And daily confirm is of a numerical type because all it contains are just numbers. And we can type dot describe. And all you can do is to just run it. So you will see that if you were to analyze this attribute, you will get the usual statistics that you find here. But it would be different if you were to analyze an attribute that is of a non-numerical type. So what you can do is to just try to think of what are the attributes that are categorical type. So we actually have covered one of such attribute earlier. It is called phase. So you will have your circuit breaker phase, phase 2 phase, or phase 3, etc. And if you were to type a dot describe, instead of getting counts, mean, standard deviation, you will get statistics like this. So it will actually treat what you have seen as a text, and then you will see that unique text and the most common text that was shown and the frequency of it. Similarly, for time series type, we also have covered such an attribute earlier, which is called dates. And it will also treat it as a text. And the statistics that you get is also different. So this is just something for you to know. Now we can just move on to the NumPy section. And firstly, you can import NumPy as NP. So for the subsequent sections, we will just type NP instead of the full form NumPy. And now we initialize a list for us to understand how to use NumPy. So it is very straightforward. You just need to type np.mean and type the list that you want to analyze on. If you were to type this and run it, you will get the mean. And true enough, it seems that it is pretty reasonable. And to find the median, you just need to type np.median and you'll get it. To find the mode, it is a bit, it's not that straightforward. It's not called np.mode, but the code itself is also pretty straightforward because it's just a one-liner. You will use pandas here instead of NumPy, and you will type in the list that you want to query here. So you can just type pd.series mode, and you will get this. What it means that this will just mean that 2 and 3 are the mode. Yeah. So if you see 0 and 1 here, you can just take it as they are the index of this is something like a data frame where they're just showing you that this is row 0 and this is row 1. And under row 0, we have 2 and 3. So it just shows that 2 and 3 are the mode. And now we can move on to skewness. So when a distribution is symmetric, mean equals to median equals to mode. And you will get something like this. Your data will look very symmetrical, and there wouldn't be a peak that is more inclined towards. But when a distribution is negatively or left skewed, the peak is shifted towards the right side. So you can see that if you were to plot out your data out, you will notice that the peak is more towards the right instead of the left. And we will call this negative skewed or left skewed. So just note that it's left skewed, it's not right skewed, even though the peak is to the right. And similarly, if the distribution is right skewed, the peak will be shifted towards the left side. And the mean is larger than the median, which is larger than the mode. So we can just do a simple exercise here. Does the list of numbers below form a symmetric distribution? Then if no, is it skewed to the left or right? So you can just type the answer below. Due to the interest of time, I will just go through this. And what we can do is to firstly find the mean. So let's just annotate this as the mean, and all you can do is type mean dot samples skewed. And remember to run this. If not, you will get an error because the program will not know what is sample skewed. So if I run this, I will get the mean. And if I were to get the median, it's also straightforward, np.median. And now to run the mode.
Quick. We gotta run through it very quick because it's closing in 10 minutes. So sorry to rush you, Rin.
Okay. So yeah, if you were to get the np.mode, it's not np.mode, but instead it's this. So what you can do is to just copy what I've written above and run it, and you will notice that 3 and 10 are the mode. And lastly, we have variance, which is np.var, and this is what you will get. Yeah. So let's get back to the COVID dataset and perform some NumPy operations on it. So this is what df.describe will get you, and you just need to obtain the mean, median, mode, variance. So the solutions will be posted on the solutions sheet later on. So you can just work on it individually and check your answers against it. So finally, we have the data cleaning section. So we have learned about nan value, which is not a number. And you notice that when we do a simple df.head and we look at the df, we realize that there are a lot of null values. This is very unsightly. And it is not, you can say that the data is not clean. So we should clean the data. And the very simple way of cleaning the data is to just firstly just try to detect the missing value so that you know what to clean. And if you just do a df.info, you'll see that there is a non-null count and a data type. So what is important is to just see how many non-null values there are. You see, for this, there are only 9 non-null values out of the 565 rows. So it shows that attributes like this have a lot of missing values and they should really be clean. So one other example is linked community cases. Instead of 565 non-null values, they only have 131 values. So you can see that there are a lot of missing values here. And you can just do is now dot sum to just see how many null values there are. And you realize that 434 will add up with 131 to form the total number of rows, which is 565. So they will add up nicely. So how do we solve such a problem? The most convenient method is to just remove the rows that contain null values. So this is a function where you can just do a df.drop_na. You can just put a column in here, and after doing that, the data frame that you get will be different. So if you were to go to the link community cases, which is here, instead of getting NA at start, you will get 0. One thing to note is that you should be one thing to note is that you will not be able to find any NA values because we have dropped all of them with NA values. And then we can add a simple visualization of the data. So notice that here, df refers to the original data frame where I did not drop any rows that have missing values. So it is a complete data. And the graph is as such, but if you were the plot will be drastically different as such. And it is quite, it makes sense because we have just dropped more around 400 rows out of the 500 rows. And that is a lot of data that is removed. So this method, even though it's convenient, it is not a good method for you to use when you want to clean the data. So another method is to just fill in the data reasonably. So if you know that missing values should be replaced with a value such as 0 or an empty string, you should use this method where you can just do a fill NA. So all you can do is to just make sure put the column that you want here, and you can type the value that you want here. So when I do this, all I will get is that a new data frame that has 0 instead of NaN. And this is one way for you to just fill in the missing data. So instead of removing those data, you'll be filling them with 0, and you will not be dropping any data. So there won't be data loss. But you need to note that you shouldn't be dropping, you shouldn't be adding a random number, like maybe like 122 or something, because this is not reflective of the actual data set. So use this method with caution. And lastly, this is just one exercise for you to fill it up the null values with appropriate values in the cumulative vexing doses and phase columns. So if you were to do that, you just need to make sure that must understand what do the data columns do. So this is a numeric data column, while phase contains textual information. So you will replace missing values here with 0, but you will replace missing data here with an empty string instead of 0, because this contains text instead of numbers. So with that, we ended the code along session. And so many thanks to our community members and for their advice and assistance in bringing you the content. And lastly, join our community today. So you could join our Telegram group, follow us on Instagram, or you can view all our links in the link tree. And we may have a mini recruitment drive in semester 2, so just stay tuned. And these are the links to today's content: the slides, hands-on, and a hands-on solution. So I will just put them in the chat. And we have ended the session for today. Thank you.
Yeah, thank you all for coming. If you have any like last questions, you can post in the pigeonhole. If not, then yeah, I'll give it like another 10 seconds. Okay, if not, then thank you all for coming. Do stay tuned for workshops in the future. Our next one upcoming will likely be a NumPy and Pandas workshop, more precisely on like different aspects of it, and it'll be done in conjunction with Hacker School by NUS Hackers. Thank you so much, and
Thank you.
we hope to see y'all with us at another workshop or career event. Yeah, do follow us on our relevant social medias, and yeah, thank you all for coming. Okay, if not, then I think we can just end it here. Thanks, Yao Min. I see you're very interested. Yeah, we will post this up on our YouTube. So you can follow our what's called our website where you can see our YouTube. Yeah. So I'm going to stop the recording.